In this video, I am going to explain about the logical operations. There are two types of logical operations, that is byte level logical operations and the bit level logical operations. Coming to the byte level logical operations, where we are going to discuss four, that is AND, OR, XOR and NOT. Coming to the AND, the mnemonic for AND is ANL, that is called as AND logical. Coming to the second one, OR, the mnemonic for OR is ORL, which stands for OR logical. The third one we discussed about XOR, and XOR stands for XRL, which is called as exclusive OR logical. Coming to the fourth one, NOT, the mnemonic for NOT is CPL, which stands for complement. Let us discuss one by one in detail. Coming to the AND operations, the mnemonic for AND is ANL. If you see the instructions, total we have six instructions related to the ANL. The mnemonic we use it as ANL, that is called as a mnemonic or the opcode. And coming to the operands, we have again two fields here, destination field and the source field. So if you see this particular instruction ANL A, #n, this instruction performs a logical AND operation between the accumulated content and the 8-bit data specified in the instruction and transfers the result to the accumulator register. Coming to the second instruction we have is ANL A, address. This instruction performs a logical AND operation between the accumulator content and the addressed byte specified in the instruction and transfers the result to the accumulator register. Third one is ANL A, RR. This instruction performs the logical AND operation between the accumulator content and the content which is there in this particular address location and transfers the result to the accumulator register. Fourth one is ANL A, @RP. This instruction performs a logical AND operation between the accumulator content and the addressed byte, like whatever the content you have in that particular address location, and transfers the result to the A register. Coming to the fifth instruction, ANL address, A. This instruction performs a logical AND operation between the accumulator content and the addressed byte specified in the instruction and transfers the result to this particular address location. The last instruction we have is ANL address, #n. This instruction performs a logical AND operation between the content which is present in this particular address location and the 8-bit data specified in the instruction and transfers the result to this particular address location. So total we have 6 instructions which are related to AND. The mnemonic for AND is ANL. Coming to the second one, we talk about R. The mnemonic for OR is ORL. So we can see all the 6 instructions where the mnemonic is ORL, and coming to these operands, it is same like AND. Whatever the operands we have in AND, like first one is ANL A, #n. We can see ORL A, #n. The second mnemonic we have is ANL A, address. We can see ORL A, address. So this particular instructions, everything is same, but the only difference is here the mnemonic will change ORL, and here in the AND the mnemonic will be ANL. So let's see the one by one again. Coming to ORL A, #n, this instruction, what does it talks about? It performs a logical OR operation between the accumulated content and the 8-bit data specified in the instruction and transfers the result to the accumulator register. Coming to this instruction performs the logical OR operation between the accumulated content and the content which is there in this particular address location and transfers the result to A register. Coming to ORL A, RR, this instruction performs logical OR operation between the accumulated content and this content which is there in this register specified in the instruction and transfers the result to A register. Coming to the fourth instruction, that is ORL A, @RP. This instruction performs the logical OR operation between the accumulated content and the addressed byte specified in the instruction and transfers the result to A register. Coming to the fifth instruction, ORL address, A. This instruction performs the logical OR operation between the accumulated content and the content which is there in this particular address location and transfers the result to this particular address location. Coming to the last one, ORL address, #n. This instruction performs the logical OR operation between the 8-bit data and the content which is there in this particular address location and transfers the result to this particular address location. So this is the description of each and every instruction here. And coming to the third one, we are talking about XOR now. XOR, the mnemonic for XOR is what? XRL. So if you see the instructions are same like ANL and ORL instructions again, but the difference is here the mnemonic will be XRL. Okay, if you see again, you can see XRL A, #n, so you can see ORL A, #n. ORL A comma address, XRL A comma address. So the instruction will be same, but the only difference is here the mnemonic will be XRL. So if you see the instructions, let us see one or two once again. XRL A comma hash n. This instruction performs logical XOR operation between the accumulated content and the 8-bit data specified in the instruction and transfers the result to the A register. Coming to XRL A comma address, this instruction performs the logical XOR operation between the accumulated content and the addressed byte content specified in the instruction and transfers the result to A register. Likewise, we explain each and every instruction in detail. Okay, but the thing is, for XORL you have to perform the XOR operation. For ORL you have to perform the OR operation. For ANL you have to perform the AND operation. And the last we discussed about the CLR and CPL. CLR-A. What is the CLR-A here? It means that the accumulated content will be cleared. Whatever the content you have in this accumulated register will be cleared. So after executing this instruction, the accumulated register is going to hold the value 00H because accumulated is an 8-bit register. So automatically it is going to hold the value as 00H. Coming to the last instruction we have, that is CPL, that is complement of A. This instruction, what does it do here? It performs a complement. Means the content which is there in the accumulated register will be complemented. Means after executing this instruction, whatever the bit you have in the accumulated register will be complemented. That is about the complement A. That is CPL is a mnemonic, A is the accumulated register. For clear, CLR is a mnemonic, A is the accumulated register. So note that no flags are affected unless the direct RAM address is the PSW. Okay, like we have seen PSW registered in the first unit, so in that you have a carry flag bit and so on. Okay, that will be very clear, like when you do the programming based on this particular instructions. You can do this particular example and what are the contents of the register A and the memory location 15H after executing the following code. You have to do everything and find out what is the content of register A finally, what is the A contents and what does the 15H memory location contain, what actual data the 15H memory location contains after executing the following code. This is a solution, you can check it out, find out. Finally, A is going to have the value 00H and 15H is going to have some data. So you can check it with executing each and every line. Thank you.